you can simply just bring earth field dams because they are easier to construct and material availability is fine and good. That's not the case, but there are certain aspects that we need to just consider first before which type of dam is to be um, uh, suitable for a given site, right? And then project um, conditions, social conditions, and then so on. There are several conditions and factors which are just used to select a given type of dam. It's rare that for any given site, only one type of dam may be suitable. You can have different alternatives. You may have gravity dam may be suitable, or number one, or embankment dams may be preferred, or maybe arch dam may also come into vote. And then you can just select the one which best suits for a given site under consideration. And there are in fact several factors which affect suitability of a given type of dam in a given site or location, including topography, material of construction, spillway size and the location, seismic activity or action in the area, foundation conditions or geological setup of the foundation of dam site and reservoir and so on. So there are quite a lot of factors which are affecting the dam site, the dam type selection for a given for a given site, right? So topography is the one. That's the first criteria that to be considered, right? Which is reflected with respect to the shape of the valley, right? Topography is valley shape used, right? ለምሳሌ narrow V-shaped valley ሊያጋጥመን ይችላል at a certain location. So a narrow V-shaped valley with sound rock and abutments has an arch dam as the first choice ነው የሚሆነው ማለት ነው. However, for economic arch dam, it is preferable to have the top width of the valley shall be less than about 4 times its height. We will just see that one actually, how valleys are just getting suited for arch dam or concrete gravity dam. It's also suitable for rockfield dam, right? A V-shaped valley. A valley which is just having V-shape when you just observe it from downstream to upstream or from upstream to downstream. ከአፕስትሪም ወይም ከዳውንስትሪም ሆነን ቫሊዩን በምናይበት ጊዜ ቪ ቅርጽ የሚሰጥ ሼፕ መጀመሪያ ለአርች ዳም suitable ነው because arch action fully እንዲኖር ያደርጋል ማለት ነው። ነገር ግን the foundation requirement or the integrity of the abutment also is coming into picture. That's another factor. Of course, we will come to that one, right? So with sound rock, because if there is no sound rock in the abutments and in the foundation, that means it is not able to handle the load that's coming to the abutments and the foundation. That means we need to have the sound rock abutments and foundation, as well as V-shaped valley is available. Then the choice may preferably go for arch dam. It can be also suitable for rockfield dam. On the other hand, a narrow or moderately wide U-shaped valley with sound rock foundation is best suited for gravity or buttress dam, right? That is another alternative if you have U-shaped valley rather than the V-shaped one. You may just encounter wide valley, which is not simply U-shaped one or kind of V-shaped one, but it's a wide valley with foundation of soil material to considerable depth. That means overburden, deep overburden. Then in that case, we may just go for earth-fill embankment dam, right? So earth-fill embankment dams are most often preferable for various types of foundations, including weak foundations. In fact, there should be some sort of treatment for foundation in that case, should be there, right? So you can see here, this figure, for example, it's just a kind of V-shaped valley, right? Um, um, I'm just looking for some material to use from here, but I can't get that one anyway. See this one. This one is just kind of nearly U-shaped. It seems V-shaped, but it's U-shaped valley, right? So in this case, this one is just a gravity dam, concrete gravity dam, and as you can see, it's just having a kind of sound abutments, and then this one is just a gravity dam in operation. So U-shaped value is good foundations, suitable for gravity dam. See, this one is just Glen Canyon Dam, which is arch dam in USA. So this is a case of V-shaped valley with sound rock abutments. So the abutments, when you see them, it's really sound rock, right? So this is an arch dam. That's the case of massive arch dam, right? Well, this one is the case of arch dam. Also is the case where V-shaped valley have been there, and then you can see here at the bottom you have very small widths of the river, and then the valley just widens like this one, right? V, it just gives you the V shape, and then it's suited for the construction of arch dam. In fact, there was some problem during the construction in the case of Tekeze Dam, but that was later on resolved, specifically yielding of the abutment encountered at one occasion during the construction period, right? So these are just the case of buttress dam. Still, the case was similar to the case of gravity dam, U-shaped valley with sound rock foundation and abutments. And then these are actually the buttresses, which are downstream, supporting the sloping slab membrane, which is directly in contact with the reservoir water here. And then they are just suited for U-shaped valleys, uh, as the same as that of the gravity dam. Rockfill dam or earth-fill dams for wide valleys. You cannot simply say it's U-shaped or V-shaped, but the valley is quite wide that in that case, we may not just provide arch dam or gravity dam or buttress dam, because for one thing, the material of construction is costly to provide, and as the other one is, the intended purpose of arch action. In the case of arch action provision cannot be just possible. Then in that case, we may just go for earth-fill and rock-fill dams. This one is the rock-fill dam, and this one is just the earth-fill dams. And then in that cases, you have seepage quite important. And the seepage cannot go away, right? So in the case of embankment dams, right? So this is wide valley in the case of Egypt. That's just the lower part of the Nile ridge, and then you can expect that the valley is wide at the lower areas. But in upper catchment areas of the Nile, you can have just V-shaped valleys, you can have U-shaped valleys, and then so on. And then in that cases, you may just go for concrete gravity dams, RCC dams, or other suitable types of dams, because the valley shape dictates the type of dam to be employed in that particular site. So this is downstream ወደ ታች ስለሆነ በአብዛኛው ታችኛው ወይም ሎየር ፖርሽንስ ኦፍ ሪቨር ሜዳማ ነው ራይት ዋይድ ቫሊ ነው ቫሊ በሪቨር ኮርስ ቢኖርም ዋይድ ቫሊ ነው and then you can see it's just very long dam crest lengths okay so that's one high dam rockfield dam in Egypt. The other factor which affects the selection of dam type is the foundation or the geology which is under consideration. Foundations have to carry the weight of the dam. The dam site must be thoroughly surveyed by geologists so as to detect the thickness of the foundation strata, presence of faults, fissured materials, and their permeability, slope, slip, etc. Okay, so the foundation structures something related to the foundation conditions, the geological setup. That's really important. So in nature, you can encounter quite a lot of foundations, such as solid rock foundation. If you're lucky, then you can just get solid rock foundation, which is having good integrity. Okay, ጠንካራ የሆነ rock foundation ሊገኝ ይችላል። ይሄ ምንም ጥያቄ የለውም። It can bear the massive structure that you are just bringing down. But that one is not most of the time the case that you may encounter. You may just encounter gravel foundations and a coarse sand, something heterogeneous foundation ሊኖር ይችላል። Silt and fine sand foundation ሊያጋጥመን ይችላል። Clay foundation ሊኖረን ይችላል. Or you may just encounter non-uniform foundation in the dam site, right, on the proposed dam site. And then, of course, non-uniform foundations is just most of the time the practical situation in the field. ምክንያቱም ዩኒፎርም የሆነ ነገር አብዛኛውን ጊዜ ላይገኝ ይችላል። ነገር ግን የተለያየ some portion of the dam or the foundation is clay ሊሆን ይችላል. The other portion is silt and fine sand ሊሆን ይችላል. Elsewhere you may have gravel portion ሊኖረን ይችላል. And then so on, spatially vary ሊያደርግ ይችላል from reservoir area to dam site, downstream of the dam, upstream of the dam, proposed site የተለያየ ሊሆን ይችላል. So most of the time is just it's non-uniform foundation ሊያጋጥመን ይችላል ማለት ነው. Anyway, in that case, how we just go with that one, treatments of foundations are important. We are dealing with one proposed dam quite nearby us here in Urbamich a couple of days ago. And then the geology and the foundation conditions were really disappointing. That the geotechnical investigation shows that at the center of the valley there was a weak foundation, but at the embankments it's just giving them good result. But even the depths of the bedrock they could not get at the center, and then they were disappointingly to miss the site because they could not able to construct any type of dam because of the fear of seepage, right? So it's really pressing and the determining factor, which is the geology and foundation conditions. If they are, not giving you good results, if the foundation is something weak, and then if there is a problem of the bearing of the foundation, or if there is a problem of seepage anticipated, then actually what's the point now? You have to just bring it down, right? So that's really, really the case, and then that's quite important. In the case of solid rock foundations, the bearing capacities of these types of foundations is good, and the resistance to erosion and percolation is well. So any type of dam can be constructed in such types of dams. But that one is just a chance of luck that you may have it or you may not have it. However, the choice of the type of dam will be governed actually by the other factors, such as economy of material or overall cost of the project, the valley shape, um, you know, nearness to the intended purpose, and there are several other reasons. But based on the geology and foundation criteria, the solid rock foundation is the best and the foremost one. Well, certain times you may have solid rock foundation, but that foundation may consist of some weaker materials, such as weathered rock, such as some weak zones in it, some openings in it, some cracks elsewhere in the dam side or in the reservoir area may be there. So in that case, you may just look for treatment of the foundation, such as sealing of the openings, the fractures, by different means such as grouting, which may just fill up the voids or cracks very well, and then you may just use that site for construction of a given type of dam. Anyway, solid rock foundations are very good. We can have also gravel foundations and a coarse sand. If well compacted, such foundations are suitable for earthy fill, rock fill, and low concrete gravity dams. Dams having heights less than 15 meters. As these foundations are frequently subject to water percolation. So seepage, foundation seepage, is a tempting problem here in this case, in the case of gravel foundations. Special precautions must be taken to provide effective water cutoff or seals. በዚህ ኮንዲሽን ምናልባት ቤድሮክ በጣም ባይሪክ cut off ፕሮቫይድ ማድረግ እንችላለን then that's foundation treatment የምንለው ነው. As far as bearing capacities of these types of foundations are considered, ስለዚህ massive high dams bear ሊያደርጉ አይችሉም. But earthy fill, rock fill, low concrete gravity dams ሊመጣ ይችላል ማለት ነው. Okay? So foundation treatment essential in such type of dams. If other criteria just favor the construction of dam as a particular site, but foundation limits as gravel foundation, then in that case gravel foundations need to be compacted well, treated very well, and then you may have just bring the dam at the site as required, right? The other one is silt and fine foundations. These foundations suggest the adoption of earth dams or very low gravity dams, not more than 8-meter height. That is, if you're actually bringing, high dams more than this, then the settlement issue will be serious, and then overtopping will be there, and then the whole project and then the system may be in trouble. So the dam height as concrete gravity dam considered should be very low, but earthy fill dams can be constructed on such type of foundations, but they are not suitable for rock fill dams because of the settlement problem. The main problem is settlement, the prevention of piping, right? Excessive percolation loss, protection of foundation as a downstream tool from erosion, right? In the case of a silt and the fine sand foundation, okay? Clay foundations, this can be used to support earthy fill dams after special treatment. እነዚህ ፋውንዴሽኖች special treatment ያስፈልጋቸዋል after consolidation of the foundation actually. The behavior of clays is that it holds water for a long period of time. And then if it holds water for a long period of time in the foundation, what will happen is that, the uplift pressure on the dam bottom will be very high. So that should be avoided, right? And then to avoid that one, the clay should be consolidated. That's the foundation. Clay should be consolidated, meaning the water from the foundation, from the clay foundation should be removed. Of course, there are methods to consolidate clay, and that's there. Since they may be subjected to considerable settlement, because obviously clay ውሃ ሲያገኝ expand ያደርጋል። ውሃ ሳያገኝ ሲቀር ደግሞ shrink ያደርጋል when there is dryness. Shrinking and swelling behavior አለው. And then that actually brings us, the issue of settlement quite high in the case of clays. So clay foundations should be treated very well by consolidation mechanisms and then by other treatment ways. So clay foundations ordinarily are not suitable for construction of concrete gravity dams. That they are not suitable because of the excessive settlement that's expected. And then rock-fill dams also, they are not just employed on clay foundations because of the settlement problem. Finally, you have non-uniform foundations, which is just the physical and the practical cases in the field. You have quite a lot of different materials in the foundation. That's non-uniform. That's where gravel, somewhere clay, and then you may have non-uniform foundation of rock. Soft material may have to be used if the dam is to be built. Such unsatisfactory conditions have to be dealt with by special designs or appropriate foundation treatment. So you may not just treat one place, but you may just treat different places, either in the foundation of the dam or in the reservoir area. So that's actual condition ጋር ትንሽ የተቃረበ የሚመስል ማለት የተለያዩ ማቴሪያሎች ፋውንዴሽን ውስጥ ሊኖሩ ይችላል ራይት ግማሹ ሮክ ሊሆን ይችላል ዌዘር ድሮፕ ሊሆን ይችላል ክላይ መሃል ላይ የሆነ ቦታ ሊመጣ ይችላል እንደንሶ ናን ዩኒፎርም የሆነ ፋውንዴሽን ሊኖር ይችላል ማለት ነው The other factor governing the selection of dam type is materials for dam construction. አሁን የሆነ ዳም ልንገነባ ብናስብ ማቴሪያሉን ከየት እናገኛለን የሚለው ሌላኛው ክራይቴሪያ ይሆነናል ማለት ነው ራይት የዳም ሳይት ኢንቨስቲጌት ሲደረግ ማቴሪያሉን ከየት እናመጣለን ከየት እናገኛለን ከሩቅ ነው ከቅርብ ነው የሚለው አብሮ የሚሄድ ነው right materials for dam construction right that actually goes with the transportation of materials ለምሳሌ ከሩቅ ቦታ የሚመጣ ማቴሪያል ከሆነ የዳም ታይፑ ሊወድቅ ይችላል ማለት ነው በዛ ምክንያቱም ትራንስፖርቴሽን ኮስት ሃይ ይሆናል ማለት ነው ያ እንዳይሆን ማቴሪያል ኦፍ ኮንስትራክሽን በቅርቡ የምናገኘው ማግኘት የምንችል ሊሆን ይገባል ማለት ነው So elimination or reduction of transportation expenses for construction materials, particularly those which are used in great quantity, በተለይ በብዛት የምንጠቀመው ማቴሪያል ለዳም ቦዲ ለምሳሌ ኮንክሪት ሊሆን ይችላል or masonry ሊሆን ይችላል ሮክ ሊሆን ይችላል ሶይል ሊሆን ይችላል አብዛኛው ጊዜ እነዚህ ናቸው እና እነዚህ በቅርቡ ሊገኙ ይችላሉ ወይ if that's not available quite near or reasonable distance from the dam site, then the cost of transport will be very high. Then that may determine the type of dam at a given site, right? So availability of suitable aggregate, such as sand or gravel or crushed stone for concrete is a factor favorable to the construction of concrete dams. On the other hand, if suitable soils are available, in a site, the choice may be for an earth dam or rock-fill dam. ለምሳሌ rock-fill dam foundation ስንቆፍር በጣም abundant quantity የምናገኝ ከሆነ ወይም removal of weak zones in the foundation በምናካሄድበት ጊዜ a large volume of soil material የምናገኝ ከሆነ sand material የምናገኝ ከሆነ maybe rock-fill or earth dam may be suited or we may have the material of construction quite nearby በጣም በቅርቡ በአቅራቢያ ማግኘት የምንችል ከሆነ then that may dictate the selection of a given type of dam ማለት ነው The other one is spillway size and the location. ይሄ ባለፈው ዳም ክላሲፋይ ስናደርግ based on the hydraulics of dam. Okay, that's overflow section and non-overflow section ብለን ስናካፍል ዳሙን ለሁለት ነው የከፈልነው። that's overflow type of dam and non-overflow type of dam ብለን ልንከፍላቸው እንችላለን። ከነዛ ውስጥ overflow type of dam የምንለው is directly spillway, right? And then this is spillway in storage dams specifically is meant for allowing of flood water to flow over it. ስለዚህ ውሃ ለማፍሰስ ብዙ ፍለድ ወይም ጎርፍ በሚመጣበት ጊዜ ዳሙ ከአቅሙ በላይ እንዳይጨነቅ ማስተንፈሻ ማለት ስፒል ወይ ስፒል ማለት ያው ማፍሰስ እና ወይ ማለት ደግሞ መንገድ ነው የማፍሰሻ መንገድ ብለን ልንለው እንችላለን። የሱ ሳይዝ እና ሎኬሽን ያለበት ቦታ አንድን ታይፕ ኦፍ ዳም ሊወስን ይችላል ማለት ነው። what does it mean? spillway size በጣም ትልቅ በሆነ ቁጥር almost all the sections are becoming constructed with the rigid type of material, mainly concrete ይሆናል ማለት ነው። ስለዚህ ትንሽ የቀራችውን ቦታ በኤርዘን ማቴሪያል ከምናመጣ ራሱን ኮንክሪቱ መዝጋቱ ይሻላል። ምክንያቱም concrete is a different material and then soil is a different material. ለምሳሌ ኮንክሪት እና ኤርዝፊል ዳም ኮንስትራክት ብናደርግ ኤርዝፊሉ አለ ኮንክሪቱ አለ። ሁለቱን ስናገናኛቸው መሃል ላይ specifically at the joints it's just a very weak point. ምክንያቱም ሁለት የተለያዩ ማቴሪያሎችን አንድ ላይ ስላመጣን ማለት ነው። ነገር ግን አንድ አይነት ማቴሪያል ከሆነ ሆሞጂኒቲውም አለው ቦንዱም ትልቅ ነው integrity of the structure will be high. ስለዚህ spillway size በምንልበት ጊዜ spillway size በጣም ትልቅ ይሆንና አንዳንድ ጊዜ which is dependent upon the flood that's expected to be generated at that particular dam site, which is mainly depending upon the surface hydrology at that particular place, right? So hydrology የሚመጣው ማለት Q design የሚለው maybe 100 years return period ሊሆን ይችላል። okay ወይም 50 ዓመት return coefficient discharge. You have L is equals to spillway length, right? And then H, the height over the crest, the height of water. The head, I think, rather than that, the head, that's more technical term according to hydraulics. The head over the crest, right? ስለዚህ አሁን for example, if you take one valley, ለምሳሌ if this is the valley, and then if we are just intending to construct a dam here, say ይህን ያህል height dam provide actually ይሄ ከupstream ከዳውንስትሪም ወደ አፕስትሪም ስናየው ወይም ከአፕስትሪም ወደ ዳውንስትሪም በምናይበት ጊዜ ሊሆን ይችላል in empty reservoir condition እና this is just dam ቢሆን then ለምሳሌ spillway መሃል ላይ ቢሆንና right, so let me just use that one with this one. It's not showing. ይሄ spillway ነው እንበል ይሄ portion ነው ማለት ነው right so this is overflow section ወይም spillway ብንል እቺ ከዳር የቀረችው ናን ኦቨርፍሎ ዳም ወይ ዳም ሲሰየም በናን ኦቨርፍሎ ዳም ለምሳሌ ኤርዘን ማቴሪያል ከሆነ ኤርዝ ፊል ብለን እንጠለው ማለት ናን ኦቨርፍሎ section right meaning እቺኛ section እና is እቺኛ section ማለት right ይሄኛው overflow section meaning በተወሰነ actually ከዚህኛው ዝቅ ማለት አለበት in real design and real construction overflow section በተወሰነ ከዋናው ዳም ዝቅ ይላል ማለት ነው now the point is now ይሄኛው this one you can imagine that almost all the section of the dam is just overflow section or spillway ስለዚህ ይሄን ዳም እዚህ ጋር ሌላ ማቴሪያል አምጥተን ኮንስትራክት ከምናደርግ በኮንክሪት ወይም ሲሚላር ማቴሪያል as overflow section ጋር ካለው አንድ አይነት ማቴሪያል አምጥተን ማሙላቱ ይሻላል ስለዚህ ዲተርሚን ያደርጋል ማለት ነው spillway ሳይዙ ዲተርሚን ያደርጋል ማለት ነው but if we have very small section on the other hand you may imagine that your dam is say it's like this one and then say dam የምናደርገው ምናልባት እዚህ ጋር ቢሆን ምናልባት spillway እቺ ብትሆንስ right spillway እቺ area ብቻ ብትሆን right you see it's just quite large portion non-overflow section ነው ማለት right so in that case the size of the spillway is quite small right non-overflow section ስለዚህ in this case the spillway is very less right so in this case spillway size is very less right? So in this case the dam type may not be governed by the spillway size right ነገር ግን በዚህኛው on this case the spillway size determines the dam type because ከራሱ ጋር አንድ እንዲመሳሰል ነው የሚያደርገው ማለት right so that's actually the spillway size ብለን how the spillway just affects the type of material I mean the type of dam in a given site የምንለው ከዚህ ጋር ከዚህ ኮንሰፕት ጋር ይያዛል ማለት ነው hope you are clear with this one spillway ማቴሪያሉ ሁሉ ጊዜ ኮንክሪት ግራቪቲ ለምሳሌ ኮንክሪት ነው በአብዛኛው ጊዜ። ስለዚህ ሳይዙ በጣም ላርጅ ከሆነ that means the length, right? actually length የምንለው ይሄ ነው, right? here is the length ከዚህ እስከዚህ, right? ይሄ ማለት if the length is very large, ሳይዙ large ነው ማለት, then in that case it obliges us to construct the same material as that of the spillway. Concrete gravity dam እንዲሆን dictate ያደርጋል ማለት ነው. On the other case, if it is quite less, then in that case it just gives us that the spillway size has no determining capacity for it to be like that one, right? So actually the length here is very small. So in this case, የግድ spillway material አይነት type of material መጠቀም አንገደድም, ምክንያቱም quite large portion of the dam is the other type of material መሆን ይችላል ማለት ነው, right? So how this one? spillway size እና location የምንለው ለዛ ነው ማለት ነው. okay, location ደግሞ spillwayን center ላይ እናደርገው or towards the abutments እናደርገው, or we have to provide it quite separate from the dam የሚለው under question ሊመጣ ይችላል ማለት ነው. አብዛኛውን ጊዜ if concrete dam በሚሆንበት ጊዜ spillway can be anywhere ሊሆን ይችላል, ምንም ችግር የለውም. ነገር ግን earth fill እና rock fill በሚሆንበት ጊዜ spillway location just ከግምት ውስጥ በጣም ይገባል, ወይም it's just critical to consider. ምክንያቱም earth fill ሌላ ማቴሪያል ነው, እንደገና ደግሞ ኮንክሪት ሌላ ማቴሪያል ነው. ሁለቱ በአንድ ላይ ስለሚመጡ ዊክ ዞን ይኖራል ማለት ነው. ስለዚህ ሴፓሬት ፖርሽን ቢኖርን በጣም ቆንጆ ነው. that means spillway ለብቻው ሌላ ቦታ as a saddle dam case አይነት ቢኖር that's preferable. ነገር ግን if it is not possible to get such a saddle portion for constructing a spillway for earth fill embankment or rock fill embankments, then the spillway should be placed near to the abutment. በተቻለ መጠን ወደ abutments ተደርጎ construct ቢደረግ ይመከራል ማለት ነው. So location of the spillway as well as the size of the spillway determines the type of dam የምንለው ከዚህ ተነስተን ነው ማለት ነው. okay, the spillway is a vital appurtenant structure of a dam. Frequently its size, type, and the natural restrictions in its location will be the controlling factors in the choice of the type of dam. Spillway requirements are dictated primarily by the runoff. Now, spillway capacity determined የምናደርገው በrunoff ወይም በhydrological analysis ነው ማለት ነው, right? The cost of constructing a large spillway may demand the adoption of concrete overflow dam for the purpose of combination of the structure with a rigid structure, right? Large excavated material from separate spillway channel may be utilized in dam embankment. An earth fill dam may prove to be advantageous. ለምሳሌ አንዳንድ ጊዜ saddle portion of dam ሊገኝ ይችላል. ያን saddle portion valley ካገኘን we may just excavate that saddle portion and then use the material from that portion to construct the dam, and then we are just constructing spillway in the saddle portion. በአንድ ድንጋይ ሁለት ወፍ እንደማለት ነው. አንድም የቆፈርነው አናጣው ወይም ዝም ብለን አንጥለው, እዚህ አምጥተን በሌላኛው በሜን ቫሊ ላይ ዳም ኮንስትራክት እናደርጋለን ማለት ነው, right? that's the advantage ማለት ነው. አንዳንድ ጊዜ small spillway requirements often favor the selection of earth fill or rock fill dams, even in narrow dam site በሚሆንበት ጊዜ ማለት ነው, right? Well, this is just saddle dam example. ለምሳሌ this is just the main river ይሆንና እዚህ ጋር ምናልባት ዳም ፕሮቫይድ ልናደርግ እንችላለን። እዚህ ዳም ስናደርግ actually the river is just coming like that one. ምናልባት when you are just constructing main dam here, you may have a saddle portion. ዝቅ ያለ ቦታ ወይም ዝቅ ያለ ቶፖግራፊ in the valley ሊኖር ይችላል። ስለዚህ በዚህ ምናልባት saddle dam ፕሮቫይድ ልናደርግ እንችላለን። that can be serving as spillway ሊሆን ይችላል። እዚህ ጋር earth fill ካደረግን እዚህ ጋር saddle ዳሙን ኮንስትራክት ማድረግ እንችላለን ማለት ነው። in fact preferably ነው እንጂ የግድ እዚህ ጋር saddle ዳም ካለ ሁሉ ጊዜ earth fill እና spillway ይመጣሉ ማለት አይደለም። preferably ከተቻለ that is the foundation conditions, the topography, and then other conditions dictate በሚያደርጉበት እንደዛ እናደርጋለን ማለት ነው። ኦኬ saddle dam ፕሮቫይድ ይደረጋል። አንዳንድ ጊዜ saddle dam ራሱ non overflow dam ሊሆን ይችላል። ምክንያቱም we don't want to lose the water። ምክንያቱም እዚህ ጋር if we just do not dam it, then this reservoir would not happen. እዚህ ሾልኮ ሊሄድ ስለሚችል ማለት ነው። ስለዚህ we need to plug it. Okay, we need to provide barrier here, that's saddle dam. And this one is a main dam. ነገር ግን አንዳንድ ጊዜ ይሄኛው እንደ spillway ልንጠቀመው እንችላለን። If this one is earth fill dam or rock fill embankment ከሆነ one type of material, that's rock fill or earth fill, እዚህ እንጠቀምና gravity section or overflow section እዚህ ጋር ልንጠቀመው እንችላለን ማለት ነው። የተለያዩ ማቴሪያሎች ስለሆኑ አለያይተን መጠቀም እንችላለን ማለት ነው። Right? That's just an example. The other factor which governs selection of a given type of dam is earthquake, seismicity የምንለው ማለት ነው። አንዳንድ ጊዜ ይሄ earthquake prone areas የሚመጡ የሚሆኑ ነገሮች አሉ። What earthquake brings is etc. added load ነው የሚያመጣው during its occurrence. ስለዚህ ያ ታሳቢ ሊሆን ይገባል because it's just a very huge amount of inertial load getting created within a very short period of time, which can destabilize the dam and damage the dam, or destruction may happen to the dam due to earthquake. ስለዚህ ያ ከግምት ውስጥ ሊገባ ይችላል. But it does not mean that everywhere earthquake is there, no. But there are areas which are known from historical experiences and then historical information. There are earthquake prone areas out there. If the dam lies in an area that's subject to earthquake shocks, the design must include provisions for added loading due to inertia and then stresses coming thereof. Also, by including the provisions for added loading due to the earthquake in the design of any type of dam may be adopted in these areas. Earth fill and concrete gravity dams are the best suited types in this respect. አብዛኛውን ጊዜ earthquake-ን መቋቋም የሚችሉ ዳም ታይፖች ምንላቸው earth fill እና concrete gravity dam because of their inherent stability nature. ሌሎቹ ለምሳሌ arch dam ብንወስድ it's just complicated because yes እንዴት ነው አለ So the earth fill and concrete gravity dams are the best suited types in this respect, right? Because if you take the arch dams, you know, the profiles of these types of dams are quite sensitive for any kind of destabilizing load. So in that case, they may be, you know, prone to failure in the case of earthquake. So comparatively, the gravity dams and earth fill dams are quite suitable for earthquake-prone environment. You can see this one earthquake seismicity region in Ethiopia. There are different regions. Region 1, 2, up to 4 are there. Region 4 is quite serious one, in which case you need to just take care about that one, right? That's mainly the Rift Valley region, um, the central region of the Rift Valley. Then it actually um, reduces towards to the north and the southern regions, as you can see, when you are just going far away from the center of the valley. So dams which are to be constructed in the case of Rift Valley should be considered for earthquake loading, right? Earthquake tremor may be there, and then designs should consider that one, right? Yeah, this is in nutshell the different factors which are affecting the dam type selection for a given type of dam. In fact, you cannot just take one type of factor or one factor to decide um, a given type of dam in a given site. You have to have different considerations and factors to come together and then decide the best alternative. You may have two, three, four alternatives of site may be there. In one, you may have earth field embankment may be best, and the other may be gravity dam may come. Elsewhere, you may have buttress dam may be an alternative, and then you may just just work out all the factors which can come together, and then provides you the best alternative, and then just select the type of dam for a given site, right? So if you have any question, actually, you may just forward it to me at a later time through chats and then through the emails also possible. The next one is actually the investigation of dam site. Obviously, after just selecting the type of dam, and then the site is fixed now, and then after that, investigation of dam site just comes into picture, right? So this dam site investigation requires careful planning, and a considerable investment of time and the resource is important for this one. Wherein in situ tests, field tests, laboratory tests, and then other studies in the investigation of dam sites are just included, which are geological investigations, geotechnical investigations, the hydrological investigations, engineering ones, and so far there are quite several of them are there, right? This is actually includes, you have reconnaissance studies, then preliminary survey studies are coming, and finally, you need to just go for detailed investigations at the end of the day for a given site. But before that, you have actually a lot of investigations before coming to deciding one site to be the possible site for a given type of dam to be constructed. Extensive investigations, including the nature of the soil, foundation material, rock formations in the foundation, the foundation competence, including the bearing capacity, the properties of the foundation material, such as the hydraulic conductivity, which has many things to do with the seepage analysis at the end of the day, right? Quite important. The deformability of the foundation, effective impermeability, and then so on. All these should be assessed in relation to the type and size of the dam proposed. What has been said so far is that investigations in dam projects can consume up to 3% or even 5% of the project cost. Well, that's actually important because before bringing such a game-changing structure in an environment, you need to just investigate that very carefully. There are several issues that need to be investigated before, such as, for example, the settlement issue, in which you are going to remove settlers from reservoir area or even from the dam site if they are there, which is important. That's the social issue. You have the hydrological issue. You need to just determine the peak flood that's expected to just occur in the site, which may damage the structure if not well investigated during the study time. The foundation issue, the structural analysis, the hydraulic aspect of the dam, all should be investigated very well as a design stage. Otherwise, the dam projects quite critical and needs question. Overall site viability is additionally subject to economic considerations, economic feasibility of the project, notably site preparation, the availability of construction material costs, transport costs, accessibility of the site for easy construction, seismicity of the site, assess development, the operation and maintenance procedures of the dam, all should be investigated as a design stage, right? Including environmental considerations. Well, when we just investigate the dam site, actually, we pass 3 major steps. The reconnaissance, that's just a kind of walkthrough survey. You don't just do much investigations or analysis and a data collection, but it's kind of walkthrough survey, just watching what's there in the site. That's reconnaissance. Then after reconnaissance, you may have 1, 2, or 3, or even more anticipated sites may be there. And then for them, you need to have just carry out preliminary investigation. And then from these preliminary investigations, you need to choose the best alternative, which is feasible from the point of different aspects. And finally, just come for the final investigation. So in the final investigation, you need to have only one site, actually, not 2 or 3 or many sites. Now, the preliminary investigation aided you to come to the final site, where you have to construct, where you have to just design your dam. Then there, quite detailed studies, detailed investigations, even topographic surveys are just done with detailed investigations or detailed data collection. The geological aspect, the geotechnical aspect, the structural aspect of the dam is refined here in the final stage, right? And then after that, actually, you just go for construction, which is actually the other aspect of dam construction. Reconnaissance involves visiting all available sites which have the possibility of being utilized and gathering information which will be useful for planning the detailed surveys and investigations. The information to be collected may include geological data without any kind of subsurface exploration, right? አንዳንድ ጊዜ ጂኦሎጂስቶች የሆነ እንደ መዶሻ አይነት ነገር ይዘው ይሄዳሉ፣ right? ከዛ ሮክ ታይፑን አይደንቲፋይ ለማድረግ ይሞክራሉ። just reconnaissance ይዘው ይሄዳሉ፣ right? Approximate estimate of stream flow, right? የግድ sophisticated የሆኑ የፍሎ estimation ወይም determination equipment ይዘን አንሄድም። ነገር ግን stream flow just floating method በመጠቀም ለምሳሌ estimate ልናደርገው እንችላለን፣ right? just it gives you some sort of clue. storage capacity ዳም እዚህ ቢሆን እንዴት ይሆናል የሚሉትን የሚያጠቃልል ማለት ነው፣ right? ለምሳሌ ምናልባት ስለ ሶሺዮ ስቴዲ የሚያደርግ ሰው ካለ እንደው ሽማግሌዎችን እዚህ አካባቢ እንዴት ፍለድ እንደሚመጣ ከዚህ በፊት ለምሳሌ መስኖ ከሆነ ይጠቀሙታል ወይ ውሃውን ለምን እንደሚጠቀሙ ሊጠይቃቸው ይችላል right እግረ መንገዱን ማለት ይያየ the head that can be available እንደዚህ አይነት ነገሮችን መጠየቅ እንችላለን ሪኮግኒሽንስ ስቴፕ ላይ ማለት ፕሪሊሚናሪ ጋር ስንመጣ ሁለት ወይም ሶስት ሳይት ካንዲዴት ሳይትስ እንመርጥና ያንዳንዱ ጋር በተወሰነ ጥልቀት ማጥናትን ይጠይቃል that sufficiently precise data ሊኖረን ይገባል in this case several sites during reconnaissance to determine the most economical and suitable site እንግዲህ ፕሪሊሚናሪ ኢንቨስቲጌሽን የሚጠቅመን ለምንድን ነው የትኛው ሳይት ሞር ፊዚብል ሊሆን ይችላል ለዲቴይል ስቴዲ የሚሆነውን ሳይት መርጦ ለማውጣት ማለት ነው ለዛ ይጠቅመናል ማለት ነው preliminary investigation usually requires less precise site survey with the resulting topographic site map large area cover በምናደርግበት ጊዜ less precise ነው ነገር ግን it gives you certain clue right የvalley shape እንዴት እንደሆነ ለምሳሌ narrow valley straight reach of a river እነዚህ ለማወቅ ይጠቅመናል ማለት ነው some investigations of the overburden በተወሰነ overhaul በመቆፈር okay detailed ብዙ ሳይሆን ከ6 እስከ 50 ሪኮመንድ ያደርጉታል እንደዛን በመቆፈር ፋውንዴሽን ውስጥ ያለ ነገር ምንድነው ዳም ሳይቱ ጋር ሪዘርቫየር ኤሪያ ጋር ምን አይነት ማቴሪያል ሊኖር ይችላል ኢዘር ቫሪዬሽን አለ ወይ በጣም የሚለው ለማወቅ ይጠቅማል ማለት ነው preliminary investigation preliminary geologic investigation and corresponding report construction material availability earthfill አለ ወይ earthfill material የሚሆን gravel የሚሆን material concrete aggregate የሚሆን material ሊኖረን ይችላል ወይ ለዛም ኢንቨስቲጌት ማድረግ እንችላለን ማለት ነው determination of public utilities such as road አለ telephone እነዚህ service facilities or utilities መኖራቸውን አለመኖራቸውን ኢንቨስቲጌት ማድረግ መቻል አለብን hydrologic studies right we can bring okay historical data wisdom analysis መስራት እንችላለን ማለት ነው right ለምሳሌ upstream መሃል ላይ downstream ብንወስድ then how can just the cubic for a given return period እንዴት ሊለያይ ይችላል ወይ ላይለያይ ይችላል ምክንያቱም it has something to do with the spillway capacity ስለዚህ እነዛን preliminary investigation time ማየት እንችላለን ማለት ነው determination of sediment load of the stream checking of high water marks for their use in determining spillway capacity and so on right ከዛ እንደዛ ካደረግን በኋላ መጨረሻ ላይ ካንዲዴት ሊሆን የሚችል the last option site extract እናደርጋለን ማለት after that we just carry out a detailed investigation for the final site that's final investigation እንለው ማለት ነው አንዷ ሳይት ላይ የጠበቀ ኢንቨስቲጌሽን ምርምር ወይም ጥናት አድርገን ለዲዛይን ምቹ የምናደርግበት ማለት ነው one of the several possible dam sites investigated is the preliminary investigation selects the final right precise investigation እዚህ ጋር እናደርጋለን ማለት ነው which involves sufficiently precise site survey and the preparation of topographic maps to serve all purposes of design construction of the dam ቀደም በፕሪሊሚናሪ ኢንቨስቲጌሽን ጊዜ ያደረግነው ምናልባት topographic survey it's only for the purpose of selection of the final site ነገር ግን አሁን እዚህ ጋር የምናደርገው specifically dam site ላይ ያለው reservoir area ላይ ያለው detailed design ለማካሄድ በሚያስችል ሁኔታ መሆን አለበት ማለት accomplishment of necessary borings test pits subsurface explorations such as geophysical testing, geologic studies and tests on the materials and foundation ሊኖር ይገባል እዚህ ጋር, right? Determination of the type of dam to be constructed, in fact እዚህ ጋር ይታወቃል ማለት ነው. Planning of the foundation treatment ምን አይነት ትሪትመንት ያስፈልጋል? Okay? In fact, in each of the subsequent chapters, we will just see the foundation treatment approach that are going to be employed. እነዛን ዲሳይድ ለማድረግ እዚህ ፋይናል ኢንቨስቲጌሽን ላይ ጥናት እናካሄዳለን ማለት ነው. Determination of the extent of land which would be submerged in the reservoir and arrangements for rehabilitation of the residents. ይሄ ከሪሴትልመንትም ጋር የተያያዘ ነገር አለ. ምን ያህል ሰው አለ ዳሙ በአንዱ ሳይት ቢሆን ምን ያህል ኤሪያ በሪዘርቫየር ሊሸፈን ይችላል? ማን የማን መሬት ሊዋጥ ይችላል? የማን ቤት ሊዋጥ ይችላል? This all should be, investigated. And then compensations, the relocations, all are just coming in the final investigation. Sufficient information for accurate estimate of cost, specification of the project እዚህ ጋር ይመጣል ማለት ነው. For bidding purpose and so on. Determination of the final location of the dam, construction equipment, labor and other staff members, probable source of construction materials, and all other information needed are just decided and finalized during the final investigation. So these are just, the investigation steps required for dam construction before design of the dam is to be commenced. So the next chapters actually just give you the design aspects of the different types of dams and so on. This is just the introductory section, which just provided you with the different types of dams, what are the basis for the classification, dam site investigation, factors which are just available for selection of a given type of dam, right? With regard to the research, you can carry out the research for an existing dam, or you can just analyze the stability of a given type of dam, but that one is of inferior quality. You need to just think deeper based on the available information, and then the performance of the dam, the geotechnical aspects, the hydrological aspects, maybe for example the uncertainty analysis for the dam, hydrological aspect. That's most of the time lacking, which you can just carry out. We can actually see that one through the next chapters. So if you have any question, please just forward, and then I can just react on that one. Otherwise, this chapter is over, and then the other chapter we can just continue next time, right? If you have any question. Okay. Otherwise, well, it's not such a big deal. You can read also, and the things are not as such difficult. You can understand by reading also. But later on, if you have points to get raised, I'm happy to just discuss that one with you. So please just do the assignments that I have sent for you, and I submit them on time, and then we will proceed for the other chapter next time. Thank you so much. Stay safe.